All right, everybody, hello and welcome back. Today we are going to work on solving quadratics for imaginary solutions. Now, we've done solving quadratics in previous lessons. There's only going to be one small difference here when we're looking for an imaginary solution, and that is going to be that, first of all, our graphs are not going to have any x-intercepts, so that's going to be our big indicator that we are going to be having imaginary solutions. But also our solutions are going to have I in them because they are imaginary. So we've got a quadratic here that says x squared minus 8x plus 9 is equal to 0. Now, in theory, we could try to factor this, but because we know we are looking for imaginary solutions, it's not going to be factorable, right? Factorable quadratics have nice rational solutions. So this one we're not going to be able to do. Plus, if you take a look, these values, my coefficients, are a little bit larger, and therefore factoring might be more challenging. So I'm going to go ahead and use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, now I need to go ahead and simplify. If I just type my discriminant, which is the part underneath my square root here, into a calculator, I will end up with negative 8 squared minus 4 times 9 is negative 80 all over 8. Now, typically in the past, what we would do is we'd say, oh, okay, we're taking the square root of a negative, so that means we have no real solution. But now we know that this just means we have imaginary solutions, so we can continue to solve. And I'm going to do that by splitting my 80 into, maybe I'll hold off on the radical part, into a couple pieces. So first, I'm going to split it up into a positive 80 and a negative 1. Remember that square root of negative 1 is going to be our I value. And now I can break up 80 into its biggest perfect square, which is 16 and 5. So when I simplify this, I have the square root of 16, which is 4, the square root of negative 1, which is I, and then I have the square root of 5 that cannot be simplified. Okay, so the last thing I'm going to want to do is I'm going to go ahead and take a look at each of my coefficients and see if I can divide out any common factors, which in this case I can. 4 goes into all of them. So I'll have x equals 2 plus or minus 1i root 5 over 8. Now, because we are dealing with imaginary solutions, complex solutions, excuse me, some people like to see our solutions split up into a plus bi form, which would look like this. 2 over 8, which can be simplified, and we'll do that momentarily. And this will simplify to 1 over 4 plus or minus root 5 over 8. I is a fully simplified version. For now, I'm okay with you leaving your solution like this, but this is the simplest form that typically we are going to want to evaluate our solutions to. Okay? So there is our imaginary solution. Again, the process is basically the same as it was before when we're solving quadratics. The only difference is now we can take the square root of negative numbers by including an I in our solution. Okay? So let's do a couple more examples. Again, we have x squared minus 4x plus 6 is equal to 0. Again, we could try to factor this, but there are no two numbers that multiply to 6 and add to negative 4. So I'm going to use my quadratic formula. We have the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now I simplify, and my discriminant once again is going to be a negative number. We have 16 minus 24, which is negative 8. And I will end up with x equals 4 plus or minus. We'll hold off on the square root and do it on the side here. If I'm taking the square root of a negative, I can split it into a negative 1 and an 8. And then 8 splits up into the square root of 4 and the square root of 2. Now the square root of 4 is 2. The square root of negative 1 is I. And that root 2 does not simplify. So here's our solution. The last thing we're going to need to do is simplify some more. So again, take a look at those coefficients here, and they are all divisible by 2. So my answer is going to be 2 plus or minus 1i root 2 over 1. And therefore, this is going to be my solution. Again, some people might want you to rewrite like this with the I value in the back. My personal thought is because we get the square root from taking the square root of a negative, because we get the I from taking the square root of a negative, whenever we simplify something so it is no longer under a radical, in my opinion, it goes in front. Again, either of these should be perfectly okay, okay? So again, very similar. This one was a little bit different because our denominator completely simplified away, which gave us a nice, cleaner solution, but again, still an imaginary and complex value in itself, okay? Now, the last problem I want to work on is a little bit different. We've got negative 2 times x minus 1 squared plus 3 is equal to 27. Now, in this situation, I am going to solve using inverses because we only have one x value in our equation. So I am going to isolate my x. I'm going to first move my 3 over, so I get negative 2 times x minus 1 squared is equal to 24. Divide both sides by negative 2 to get x minus 1 squared is equal to negative 12. Now we need to think about, okay, I need to get to my x value that's inside those parentheses. So in order to get inside the parentheses, I need to get rid of what's on the outside, and that is going to be the square. So I'm going to take the square root of both sides, which will give me x minus 1 on my left. And then the square root of negative 12, we can break up over here on the side. So it splits into the square root of 12 and the square root of negative 1. The biggest perfect square that multiplies into 12 is 4. And so we will have the square root of 4, which is plus or minus 2. The square root of negative 1, which is I, and then my root 3. Now the last thing I'm going to want to do is go ahead and add my 1 over to isolate x completely. And we get x equals, I'm going to stick it right in front, 1 plus or minus 2i times the square root of 3. Again, some people might want your solution to look more like this with the I at the end. Either one works, and here's our solution. Okay, so solving quadratics for imaginary solutions is very similar to what we did before. The only small difference is now we actually can take the square root of a negative, which we do by including an I in our solution, and the rest of the process is exactly the same. Okay. You also can't check your solution by graphing. If we were to quickly graph this, and I guess I can do it on my calculator here, just so we see what it looks like, we are going to have only imaginary solutions. And if I want to graph this, I'm going to move the 27 over, so I'm going to get minus 24 here equals y. Now if we look, my quadratic's all the way down here with no x-intercepts, so no real solutions, which is why our solutions here were imaginary. And that's going to be the case for every imaginary value. If you are to try to check by looking at the graph, then you are going to see that there are no x-intercepts, and therefore you should end up with a complex solution. Okay? As always, thank you for listening. If you have any questions or concerns, please feel free to reach out. Thanks.